Fantastic, yeah. Thank you all for coming. I appreciate it's the end of the conference. Everyone's tired. You know, you made the epic walk all the way down here, so it's, you know, we appreciate it. We didn't get the best slot out of the whole thing. You know, we're going to shoot for the keynote next year, but here we are. So thank you for coming, and hopefully you'll get what you're looking for from the session. We're going to talk today about several new features that we've released in the Azure networking space that light up some new scenarios. They were announced earlier in the week, and we're going to dive a little bit deeper and explain a little bit more about what these features are and the scenarios that they enable. My name is Jonathan Tuliani. I'm the program manager in the Azure networking team responsible for the Azure DNS service, and I'm here with Eric, who works on IPv6, and Amit. He's working on the app gateway. So we're going to talk about a number of new things here. So we're going to talk about the Azure DNS service. We announced the general availability of Azure DNS on Monday this week, and this helps you host your DNS zone and manage your DNS records in Azure. We're going to talk more about that. Something that we've been working on a long time, we're very happy to announce, is we now have IPv6 for Azure VMs. This, of course, extends the reach of your Azure application to IPv6 clients. So Eric will talk about that. And then Amit will talk about two more things. So we have the ability to put multiple IP addresses on an internal load balancer. Well, why is that interesting? Actually, there's some really interesting things that enables. In particular, high availability and better utilization when you run a SQL database in a VM. So Amit will talk about that. And then also we have some new security features in the application gateway, particularly the preview of the web application firewall. This, of course, gives you some new options for how you protect your web application in Azure. So Amit will talk about that as well. Okay. So Azure DNS. Let's, as I say, we have the general availability release of Azure DNS this week. So let's talk about where that fits within the various different DNS scenarios we have in Azure. So this is important because there's sometimes people get they mix these up. There's domain hosting for internet-facing domains. So this is what the Azure DNS service provides, and this is where you have a DNS domain, contoso.com, and you want to be able to host that in Azure. Azure provides the name servers that answer the DNS queries, and you can manage the DNS records as part of Azure, and that's what I'm going to be talking about more today. But just for completeness, there's these various other DNS scenarios we have in Azure. We have Azure Traffic Manager. This provides DNS-based routing of traffic at a global scale, between Azure data centers, and it includes endpoint monitoring of the health of your application. So in the event of a data center failure, it can do a failover to direct traffic to a different data center, a different Azure region at a global scale, at the DNS level. We also have the internal DNS service. This enables, within your Azure network, within, maybe in a virtual network in Azure, you have VMs that need to be able to talk to each other, maybe different parts of your application. And they can do that using the internal DNS service. And here the DNS is private, so within that, VNet boundary. And we also have the recursive DNS service. This is what provides all the DNS resolution. When your VM or your cloud service, when you make a DNS query from Azure, it's this recursive DNS service that is handling that query and going out across the internet to pull together the data needed to answer that query. But you also have the ability to specify your own DNS settings at the VM level, at the VNet level, so that instead of using the recursive DNS infrastructure that we provide, you can use your own recursive DNS server. And that's very common in Active Directory scenarios and so on. And Gareth is actually here, who owns both of those pieces, the internal DNS and the recursive DNS. So if there's any questions on that, we can take those after the talk. But I'm going to talk about the domain hosting, the Azure DNS service. So general availability as of Monday this week comes with a 4.9 availability SLA. And the general availability pricing, when I've got details on the pricing later on, that takes effect from the 1st of November. With general availability, of course, the service is also covered by Azure support, and it's available now for hosting production workloads. Availability and performance. When we talk to people about DNS, availability and performance are the first things they always ask about. So we feel that we do have a strong availability and performance story. So obviously we have a global network of name servers. We used Anycast-based networking so that DNS queries will be routed to the closest available name server. If one of those sites goes down, it will route to one of the other locations instead. So that all happens at the the BGP level. It also provides us great redundancy. We have a lot of a strong availability story there, for the DNS servers. But actually behind the scenes, of course, we have these are the name servers. Behind the scenes, we have a control plane that is where you manage your records. You need to create a zone, create a record, delete a record, and that is also highly available. You're probably aware that in Azure we've been going through a process of regionalizing services. An Azure Resource Manager, when you deploy a VM, when you deploy a website, your database, these are regional resources. You specify the Azure region that they're going to be placed in. Be that US Central or Southeast Asia. You specify the Azure region, and that means that that resource is running in that region. So if a different region of Azure has an incident, then you're isolated from that. But how does that work for DNS? The DNS, the domain name system, is a global hierarchy. It starts at the root zone, then .net, .com, and so on, and the country code domains, and it's a single global hierarchy. And we recognize that, and we built the Azure DNS service with global resiliency in mind. So even at the data plane, the control plane where you configure your records, that's also a global service. It spans multiple Azure regions. It's resilient to failure of multiple Azure regions. Okay. In terms of key features, obviously we support all the most common DNS record types. You can see them on the screen. I won't read them out. I will comment. We added PTR support. That wasn't available during some of the preview phase for this service. Those who are using the preview, should be aware that PTR support is now there. PTRs are for reverse DNS lookups, where instead of going from a name to IP address, you're trying to go from an IP address back to a name. So that's where PTRs are useful. And there are various scenarios for that. Azure DNS is an Azure Resource Manager service. So it doesn't exist in the classic mode of Azure, in the Azure Service Management APIs. Everything is an Azure Resource Manager for Azure DNS. And as such, it benefits from all the normal control methods that Azure Resource Manager services have. We're in the Azure portal, Azure PowerShell, and Azure CLI. And I'm happy to say that we have full feature coverage across those different experiences. I know sometimes customers are always concerned when a feature is available in the PowerShell but not in the portal, for example. But we have full coverage across there. With one extra thing to add there is one aspect that is CLI only, and that is for importing a zone file. If you have an existing zone you wish to migrate, we do have the ability to import the zone file into the service, and that we've actually done in Azure CLI only at the moment. So I'll show a demo of that in a little while. But the CLI provides the zone file import and export experience. Obviously, for developers who want to integrate DNS provisioning into a provisioning workflow, where maybe as each account you create for your customers, maybe you have a different DNS record for it. It's a very common pattern. We have the REST API and SDKs for allowing applications to integrate. And we also have been working with a partner. Obviously, we're on the Friday, so the expo is no longer available. But those who are familiar with Men in My Suite, they're a vendor providing IPAM and DNS management services, targeting particularly enterprises who have large IP pools and large domain portfolios, perhaps tens of thousands of domains in some cases. And they provide this kind of rich management experience that allows DNS to be managed at that kind of scale. And they've done the work, during our preview phase to integrate the Azure DNS service into the Men in My Suite, so that those customers using Men in My, or customers with a large DNS portfolio to manage, can use Men in My Suite to manage the domains, and that will integrate with Azure DNS, and Azure DNS will provide the name servers, the name resolution plane for that. a key part of the service is that it's part of Azure. So this means, of course, that it works with your Azure services. You no longer have to deploy your Azure service over here and then go to a separate, experience to manage your DNS. You can manage your DNS in Azure, using the same credentials and the same support relationship and the same bill and, the same role-based access control and all these other things that are, template-based deployments, all of these other things that Azure brings. You can integrate your DNS provisioning into that story. Okay. Let's talk about pricing. We're priced as with other Azure services. It's a pay-for-what-you-use model. There's no pre-commit. There's no penalty for turning off a DNS zone. It's 50 cents per zone for the first 25 zone, after which 10 cents per zone, and likewise on the DNS queries, it's 40 cents per million queries for the first up to 1 billion queries, and after that it's at 20 cents. And if you have multiple zones, this is aggregated at the subscription level so you aggregate across the zones, and then we apply the price breaks, which is in your favor. Okay. And with that, let's go to the demo. Are there any questions there? I mean, we can do questions now at the end. Just if there's anything burning, we can make a little bit now. But if there's too many questions, we'll move to the end. So I don't want to cut into the other guy's time. But if there's anything, immediately, please.
Is this going to support dynamic update for your domain controllers to register the records and of course any client VM you might have there?
Okay. So the Azure DNS service is an internet-facing DNS service, whereas typically what you're talking about with VMs and so on would be on the internal DNS service. Yeah, this is internet-facing. Now we do have an internal DNS capability in Azure, but it's separate from this service at the moment. In the long term, we are looking at how those will evolve. Any questions specific on that though? Gareth, who's with us, is the expert, so we could talk at the end of the talk about that story. Okay. Let's have a look at the demo. So let's see if we can get this to work. Give me 1 second. The machine has gone to sleep. Okay. Here we go. Okay, so what I'm going to show is in the Azure CLI, I'm going to show just how simple it is to take a DNS zone file and import it into the service. It's a key onboarding scenario. Has anyone here used the Azure CLI in the past? A couple of hands, yeah. So the Azure CLI is a command line interface. It's written using Node.js, which means it's cross-platform. You can do this on Linux. You can do this on a Mac. I mean, in this case, I'm doing it on Windows. But it's a cross-platform experience. It works exactly the same on across platforms. I've got this window which I've logged in already. I've I've executed 3 commands here already. One is I logged in, which means I did a Azure login command, and I authenticated. I've done a command, Azure config mode ARM, which, in Azure CLI, you have the classic and the ARM modes. And, this is an ARM service, Azure Resource Manager service, so I did the command for Azure config mode ARM. And then I've told it which subscription I'm using, where it's Azure account set, and then the name of my subscription, like this. So this is done already. So what I'm going to do is I'm going to import a DNS zone, which is here. So in the Azure CLI, you have these different commands, and it's a bit like a hierarchy. Azure, and then network is the bucket of commands to do with the networking in Azure. DNS, obviously, for the DNS server. It's a zone level command rather than a record set level command, and I'm going to do an import. And then the word ignite there, ignite is the name of my Azure Resource Manager resource group. Demo.net, well, that's the name I'm choosing to give the zone. And then there's the file which contains the actual DNS zone file. We can have a little look at that file. And here it is. It's a standard DNS zone file. There's a few awkward records in there. I put a giant text record in there just to see if I could break it that way. And there's various different record types there. An SPF record is there. So there's there's the zone file. So this is what we're going to do here. Fingers crossed. And you can see there's a warning there. So the SPF is a record type in DNS, which has been deprecated. The DNS RFCs now say, when they first introduced SPF, it's used for email authentication. And it's when it was first created, they said, OK, we'll make a dedicated record type for that. But then a lot of people implemented it with TXT records instead, and it was a bit of a mess. So eventually they said, OK, we're going to deprecate the SPF record type. SPF should be done using TXT records. The SPF scenario should be done using TXT records. So during the zone file import, what's happening here is the Azure CLI has read the zone file, and it will then call the Azure DNS service to load up each of the records. But where it came across an SPF record, it said, well, they're deprecated. And the Azure DNS service, as a result, doesn't support the SPF record type. It supports the RFC compliant way of supporting the SPF scenario using TXT records. So the SPF record was converted automatically into a TXT record as part of the import. So that's done. That's imported the records. If I go now over to the Azure portal, you see I'm logged into the portal here, and I'm looking at my resource group called Ignite. You remember that was the name of the resource group that I imported the zone into. So if I do a refresh here, there it is, demo.net. There's my DNS zone. So if I click here and move across there, you can see here's my zone. The name server names assigned to the zone are here. There's 4 of those. You see them here. And then further down here, I think this deleted this here because I've confused it when I practiced the demo a little while ago. I created the zone and deleted. So this time, if I refresh the browser, that will go. And here you see all the records that we imported from there. And you can see here the record with the name SPF has been imported with type TXT. There's the string that I put in it. So I think with that, we'll hand over to Eric, who is going to talk to us about IPv6. OK.
So I'm Eric. I'm going to talk to you about IPv6. And I'd like this to be pretty informal, given the hour, the day, the location, so far at the end of Building B. Thank you for coming, and if you have a question, just shout it out, and we'll talk about it. Initially, my first draft of this slide was IPv6 gaining momentum at last, but it finally has, and some 30% of US browsers actually prefer IPv6 these days. And if you look, that's not a very bright pointer, but if you look up at this right-hand bit here, this steep part, that's IPv6 preference increasing 40% year over year. So connectivity is part of, key ingredient of IPv6 success. But since the beginning of IPv6, the thing that's hampered it, one of the things that's hampered it, is lack of content. And that's changing too. According to Cisco 6 Labs, 49% of the US web content is available over IPv6 now. And these numbers are kind of similar for other countries. I mean, I picked out the US, but they're similar for other developed countries. So we're turning a bit of a corner here. Whoops, now it's going to do 2. So IPv6 enables new scenarios for existing markets and for new markets. And I've put a few of them up here that we can talk about. But these are just some examples. There are certainly more. For various reasons, over a dozen countries, governments of a dozen countries around the world are now requiring IPv6 for the cloud services that they purchase. And that market goes beyond just the governments proper, but to all the vendors and suppliers that they work with. So the government-based IPv6 market is growing. That list is increasing over time. IoT is certainly an interesting new market, and while it's just in its infancy, it's hard to know where it will end up exactly. One thing seems sure, they intend to put a lot of devices onto the network and pump a lot of data to be analyzed and stored. And so that IoT just cries out for IPv6 enabled cloud services. And speaking of a lot of devices, mobile phones are plentiful these days, and more operators are opting for an IPv6 backend in their network. So much so that Apple in June added an IPv6 requirement to the Apple Store submissions for applications. And let's not forget all that content that's out there. It's important for an IPv6 service to be able to leverage all that existing growing content out in the internet. So for these reasons, for the increase in deployment and these new scenarios that are enabled by IPv6, I am very proud to announce that IPv6 for Azure VMs is now GA'd. And thank you. And this is the first, this isn't the last IPv6 feature we do. This is the first of what will be many IPv6 features. But we think it's important for a couple of reasons. The first is that it provides IPv6 connectivity from an internet client all the way through to a native IPv6 endpoint on the VM. And this enables a lot of flexibility in the architecture when you're working with a native IPv6 connection. Secondly, these are dual stacked IPv6 and IPv4 VMs. So the same set of VMs can service both v4 and v6 clients. And lastly, with the exception of a couple of regions that are still finishing deployment, IPv6 is available globally now and will be available in all the regions, including the government and go local regions, the German and Canadian regions. In addition to the v6 connectivity, as I mentioned, we have v4 for going to the internet and also to Azure services and other VMs. So the internal communication inside the cloud is still v4, but the v6 pipe is native out to the internet. And of course, Jonathan's Azure DNS service also supports v6. You may have noticed that they support Quad A records. And so when your v6 service is created, you get both a v6 and a v4 DNS record created so that your clients can find your service easily. Go. Let's get closer. There we go. So how does all this work? Well, fairly simply, actually. This is a Azure Resource Manager picture of the load balanced networking objects. And if we start at the top there, we have a public IP object. We have a load balancer itself with its LB rules and the front and back end pools, the NIC, and the VM. Now, to create an IPv6 deployment, you have to change exactly two things. You create a v6 public IP up there with a single attribute that says this is v6. You create an interface configuration on your network with another single attribute that says this is v6. It's pretty straightforward. Then deploy with your tools of choice, templates, PowerShell, command line interface. You can also deploy a template through the portal, as we'll see in a minute. And you'll get a dual stacked VM that can, as I mentioned before, can do native IPv6 all the way to the VM. It does, because of that, it can do all the protocols, TCP, UDP, HTTPS. And it can also do outbound initiated connections, which is something that some of our competitors can't do. Outbound IPv6 connections to access some of that content and the services on the network. So we work hard to validate any service before we ship it out, and IPv6 is no exception. One example is the Office 365 document viewing service. Whenever you are using SharePoint and you click on a Word doc or a PowerPoint and that comes up in the browser, well, that's the document viewing service behind the scenes rendering that doc in the browser for you. And the Office 365 team has worked with us to provide IPv6 and is using it today for all Microsoft employees. So tens of thousands of us are all today using Azure IPv6 for Azure VMs. And I'm happy to say that the deployment went smoothly. There have been no incidents in prod, so this is all good news. A couple things I wanted to point out, though. The graph here, I know it's a bit of an eye chart, but the red line, that's the IPv6 usage, and the blue line is the IPv4 usage. So the IPv6 usage amongst Microsoft users is actually quite high, and we leverage that to help us exercise the service to make sure it's ready for you. You'll note also, this is actually the data from last week, and these are thousands of connections. How many thousands of connections are simultaneously being serviced? And you can see this little notch here is the weekend, which was somewhat surprising to the managers. And so I'm sure we'll end up with a one weekend program soon to take care of that notch. But yeah, when I talked to the Office 365 team about their v6 experience, they told me two important things. The first was the deployment went very simply, very easily for them. We talked about we just need to make a couple of changes to your template file and redeploy, and they did, and it worked smoothly. And one of the reasons that it came up so smoothly was because the second thing they stressed was they had actually worked with Windows Server on their local Windows Server boxes beforehand, porting their front-end applications to make it IPv6 capable. And when they went to the cloud, the IPv6 environment in Azure was identical to that on their servers, so it all just worked when they deployed. So they didn't have to do any code changes to transport that service into the cloud. Excuse me, I'm having pointer issues. One more time. There we go. Okay, so I'm going to do a quick demo, and this is what we're going to create. Is two VMs, and excuse me, I've got to go over here now. Two VMs with IPv4 and IPv6, and behind a load balancer. And let me get set here. Come on, come on. Okay. So we'll start with, remember that picture of that model of the load balance networking objects. Along with the documentation for IPv6 is this exact template file that's an example that will let you deploy this easily. And what we tried to do is make this as real world of an example, as useful as an example as possible. So we actually put parameters in here so that we can customize it, and you can customize it and deploy different things with different names and make it more usable for you, a better example. So there's a bunch of parameters that are defined in the file, which we'll see in a moment, that control the deployment. And then remember, we talked about creating an IPv6 public IP, and this is where it happens, where we have a public address. We have our magic statement that says this is going to be IPv6. And then remember, I mentioned we had a NIC configuration interface. We have one here for IPv4. And then a second one created for IPv6. And that's about it. So if you're not familiar with template files, I encourage you to take a look at this sample. In the documentation, it actually takes you through this template file kind of section by section and explains what's going on. But what I've done is to upload this to my account in Azure and using a new feature that's in beta called templates. I love this feature because it lets me store all my templates up there in the cloud so I can easily get at them. I say deploy, and it will actually start a template off of that. The first thing it's doing, remember I had parameterized the file, so it's asking me, for instance, what password I want to use for the admin account on the VMs, and you can see it's got it lets me pick which Windows image I want to use and which SKU and how big of a VM and where to put the storage location, all these details. We give it a resource group, choose a region, we come in here and make the lawyers happy. And then we create. And, oh, well, I didn't like one of my parameters. But not to worry. Anticipating fumble fingers, I have a bakery cooking show thing set up here. So the dough goes in, the finished cake immediately comes out. Here's the deployment. And as you can see, it creates a couple of VMs. We click on one of the VMs. And the VM has network interfaces. Here's our IPv6 NIC. A NIC has IP configurations. And here's the v4 and v6 configurations that we just saw. We also have a load balancer. And it has our v6 and v4 load balancing rules. And in this case, we did some port mapping from 80 to 8080 just for fun, just to show you that we were mapping something. And then finally, our public IPv6 endpoint. And as you can see, we have the IPv6 public address here and our DNS name for our service, Ignite IPv6. So we can look up now that this service is active, we can look it up and we can see that, yes, it does have both a v6 and v4 address associated with that service. We can even use TCPing and make sure that the endpoint's alive, which it is. Now this is I've put a web server on these VMs so that it could answer me. It has something listening. So if I say Ignite IPv6, yes, that's my DNS name. The web server is telling me, verifying that yes, now here from my desktop, I'm using v6 and connecting to my service. So that verifies that inbound, I'm doing IPv6. Now, this is a window onto one of the VMs itself. And so I'll just do a quick ipconfig. And you can see that, sure enough, the VM has a IPv6 address. And that I can go ahead and hit the service, and yes, it can see itself. But more importantly, if I go out to an IPv6 test site, this is one of the major ones, you can see that IPv6 outbound is also supported natively from the VM. So, this wasn't the most all singing, all dancing of demos, I understand that. But I'm hoping that you'll take two things out of this conversation. The first is that it's pretty straightforward to add IPv6 to your deployments, to add IPv6 to your services. Make a couple tweaks in your template file and you go. The second is that you have native IPv6 connectivity all the way in from the internet and all the way out. And then lastly, that the service is available globally today. And I checked this morning, we already have customers deploying IPv6. So with that, I will turn the presentation over to my friend Amit. Amit, take it away.
Thanks, Eric. Hi, my name is Amit Shrivastava. I'm a program manager in Azure Networking. Today I'm going to talk about two enhancements which were announced at Ignite keynote. One in Azure Load Balancer, we have now ability to add multiple IPs to an internal load balancer. This is a GA service available in all regions. I'll talk about that. And I'll talk about application gateway, the security enhancements which we have made to application gateway, including a preview of a web application firewall and a couple of other security enhancements. And I will also talk about application gateway diagnostics and a few more enhancements. So with that, let me back up and start with what are the load balancing choices in Azure. So in Azure, you have these building blocks, these NSGs, these route tables, load balancers, layer 7 load balancers, which combine together to give you an end-to-end story. In particular, in load balancing, we have these three building blocks. Azure Traffic Manager, which sits at the global level, provides DNS-based routing across different geographical regions, does a lot of things, performance-based, round-robin, failover mode kind of, as well as weighted distribution. Following that, at the data center level, we have two choices. Azure Load Balancer, which is a layer 4 load balancer, has been there since the beginning, provides connectivity within a region, specifically within an availability set. Following that, we have an application gateway which works at layer 7, provides a lot of layer 7 application level load balancing options. After that, you have all your VMs where your actual application is hosted. One thing to remember is that you can mix and match things. You can have Azure Traffic Manager talking to Azure Load Balancer, which goes directly to VM. And now you have TCP, UDP, those kind of connectivities. You can have Traffic Manager talking to an application gateway directly, which has a SLB or a Azure Load Balancer in middle. But now you have a layer 7 load balancer, which is also regionally distributed. So you can, as I said, these are building blocks. You can mix and match these things and cater to your needs. Now I'll talk a little bit about what we announced on the Azure Load Balancer. Now you have ability to have multiple WIPs on internal load balancer. The public-facing load balancer always had these multiple WIP options, but now the internal load balancer also has this capability. And you also have the ability to have a sort of a port reuse, enhanced port reuse options, which enable SQL availability group scenarios. There are many applications like the SQL availability group clusters, which require a reuse of the port on the multiple WIPs. So they want both the SQLs to be running on port 80. Now you have an ILB, which is going to these two SQL VMs. Both are running on port 80, and this feature is available on public facing as well as internal facing. So SQL in particular is doing a preview of SQL always on multiple listeners. They had the ability to do one listener because ILB supported only one WIP, but now one internal IP, but now they can have many availability groups. So the service itself is public, but SQL always on is in preview. So that's an important distinction. We are not in preview, SQL always on solution is in preview. So let's go from here to the application gateway. Application gateway is a layer 7 load balancer. It's more than just load balancer. It provides quite a lot of application delivery control features. We went GA last year, so we are a relatively new service in Azure. We went GA with SSL termination and cookie-based session affinity. Those were the two key asks from customers. And since then, we have added quite a bunch of new features, which make the offering more attractive at application layer. Specifically, we had added support for URL-based routing. This allows you to do content-based routing. You can do, as the example shows, you can have Contoso video anything which is Contoso video go to a backend pool, which could be optimized for video content. Anything which is images can go to another application pool, which is optimized differently and can be scaled differently. So you could have a static content pool, you could have a dynamic content pool, all scalable differently. We also added support for hosting multiple sites on the same application gateway. So now you can add up to 20 listeners on the application gateway, which gives you the ability to host 20 sites, IaaS sites, websites, on the application gateway behind a single application gateway. So we added that. We added support for custom health probes, where the default health probe is not sufficient for you. You can define your own routes, your own probe frequency, threshold for errors, those kind of things. We support VM scale sets in the backend. So for example, your Contoso could be normal IaaS, images could be a website, Azure website, and Fabricam could be a VM scale set, which can be scaled independently. So we have added those new features which make it more attractive for applications to be run behind application gateway from a central position. Now, it's a logical next step for us that there are these 20 websites running behind us. There's up to 20 websites running behind us. What are the security options we are providing these applications which are running behind us? Now, why is it important? Web application, there are many data points which show that more than half the attacks today are web-based. They might be slow HTTP attacks. SQL injection is an evergreen attack vector, keeps on happening. There is cross-site scripting attacks, other kinds of attacks. These make a majority of attacks today, and they are going to continue to increase. There are attacks which are catered to bypass IPS and IDS devices, firewalls, and these operate exclusively on the layer 7. And that is one of the key reasons why more and more deployments today ask for a WAF solution. Now, I mentioned a few common patterns: SQL injection, cross-site scripting. There are various protocol anomalies which you can keep seeing in your traffic today. There might be bad user agents sending bad data which does not conform to HTTP protocol. And there are various others which try to do a remote file inclusion, try to gather information, try to see what kind of web server you are running, and try to attack, change their attack pattern to target, let's say an Apache is running. So there are many kinds of these sophisticated patterns which are bypassing these IPS IDS, and this is where a WAF is able to capture them. One particular key thing which almost all WAF solutions start with is that OWASP, the consortium, publishes a list of top 10 attacks. The three above are directly from there, and there are many more over there, which are the common top 10 vulnerabilities that they see. They publish 1 in 10, 1 in 13, and we are due for a new publication. And most of the firewalls cater to these vulnerabilities, and that has been one of the design choices which we have made in our firewall as well, that we should be able to cater as many as of the top 10 vulnerabilities as possible. The challenges which most of the websites, small, big, face are that configuring these web application firewalls are inherently complex. You need to learn a new, let's say there is you go and get a virtual appliance. You need to learn a new language, you need to learn a new configuration system, you need to learn new tools, you need to learn new reporting mechanism and how to parse that. And just setting them up is inherently complex. What we have tried to do with our WAF solution is to make it very simple. It's to make it pre-configured and extremely simple, and that's what we will see. So we are announcing preview on application gateway of a web application firewall. This is offered in a new SKU. So far we have offered a standard SKU which gives all the features which I talked about a couple of slides earlier. The new SKU which has WAF will offer everything which the standard SKU has and will also offer WAF functionality. What it means, application gateway is highly available, scalable, and fully managed by Azure platform. The WAF solution which we have integrated would be highly available because one single application deployment can have up to 10 instances configured in an active-active role. These are worker instances. These are not backend instances. So an application gateway could have 10 active-active instances, gives you scalability choices, it's highly available, and the platform manages it end-to-end. If there is an instance which goes down, the platform detects it, spins up a new instance, which will be able to cater to your load, and that instance is configured with WAF and all the other ADC features which I talked about. So you don't need to learn a completely new API. You can use your familiar Azure APIs. It's fully integrated with that. How have we built it? We use mod security and core rule set. Now, mod security is one of the most popular WAF deployments in the open source world. It's almost a standard. People are comfortable, people know mod security rules, people know how to write mod security files, and there's a vibrant community around it. We have tried to reuse mod security and core rule set to protect our WAF solution, at the same time, in future, give people ability to come up with their own mod security rules, mod security files, and develop an ecosystem around it. We come pre-configured with OWASP core rule set, and we protect from these common attack vectors. These include SQL injection, cross-site, protocol anomalies. If you are trying to directly access a file or directory access, try to force browse the directories, try to force browse anything in the back end. If you are trying to crawl, we protect from those. We also protect from common security misconfigurations. We know what kind of common websites or web servers which can run behind. And if you have misconfigured them, we detect that and we protect you from that. So how do you provision this? I will, in the demo slides, I will show you how to provision and do what. But the main thing over here is that we are available only in Azure Resource Manager model. So the RM model is the go-to place for new features, new stacks, new things, new developments in Azure platform. So the WAF SKU, which I talked about, is available exclusively in Azure Resource Manager only. There are no charges today. So we will continue to, while we are in preview, we will continue to charge you in the standard rates, which you are familiar with. Before we go GA, we will announce the pricing, and we will give ample time to the early adopters to know what the GA prices are before we switch the meters. So right now, you can get a web application firewall with a few simple steps and continue to pay the standard prices. Now, since we offer in Azure Resource Manager, you get all the management options. You can manage it through Portal, PowerShell, SDK. CLI support is shortly coming. The WAF itself runs in two modes. It runs in a protection or a detection-only mode. Detection mode essentially is watch, monitor kind of mode where we look at the traffic, we raise alerts when the WAF rules are triggered, but we do not stop or prevent the traffic from going in. We log that information. So how we have configured that is every WAF alert is logged into Azure Insights. If you have used Application Gateway, you see that we have always been integrated with Azure Insights for all our logging requirements. And those include things like health log, performance log, access logs. So in the same place, you will see a web application firewall log. All the logs, all the attacks which we detect would be emitted into Azure Insights, from where it can flow directly into the customer's storage account. So it would flow, when you enable it, all the attacks it detects flows directly all the way into your storage account in a JSON file. We publish the schema in public documentation, and you can analyze that data using Splunk, Hadoop, whatever you are using, OMS, for example. So you can use any of your tool sets to analyze and set up alerts and all that. We are also going to be integrated with Azure Security Center, ASC. We are very close to completing that integration. Once integrated, what it will give the customers is that customers who have opted into Azure Security Center would have their subscriptions scanned, and the scan report will say, hey, you have open endpoints, web endpoints, which you are not protecting through a WAF. And it would then recommend a WAF solution. We would be a part of that solution. And once we are integrated with Security Center, we would emit the logs, which will go to the Azure Security Center so that you can see in the Azure Security Central portal what are the health of your backend applications and the health of the WAF solution itself. So that integration is very shortly upcoming. So this is on the web application firewall. We have also announced a couple of new features on security to strengthen the security on the gateway itself. These are not in preview. These are GA, generally available features in all regions. One is we allow a tighter control on SSL policy. Today, before this feature was not there, you did not have any control on which protocol versions, which SSL versions you can selectively enable or disable. With SSL policy, you can place a central policy on your application gateway and selectively disallow TLS 1.0, 1.1, whatever, based on your application or organizational mandates. One thing to note over there is that SSL v2 and v3 are force disabled across all gateways. We do not enable them. They are not secure. So there is no option to enable those two. They are always force disabled. So I'll show you an example of that, how to do. We have always supported SSL termination. SSL termination, your SSL is terminated at the gateway, and the data from the gateway to the backend pool used to flow in HTTP plain text, and that is not acceptable for quite a few applications. There are web applications who do not expose a AT or unsecure endpoint at all. What we have allowed with end-to-end SSL encryption is we secure communication from the customer all the way to the backend, to the VMs in the backend pools. But at the same time, we still allow you to reuse all the rules which were set on the gateway. So it's not a transparent pass-through. Your SSL session is terminated on the gateway. The gateway then applies the rules to determine which backend pool is appropriate for this request based on URL or based on host header or based on SNI. And it then picks a backend pool and re-encrypts the session, recreates a new session to the backend, and that is encrypted again. We allow whitelisting, and I'll show an example of that so that you can only talk to backend pools which you are familiar with which application gateway is familiar with, which has been whitelisted. So you could as well create a certificate which doesn't have the same CN as the incoming request, but if you have whitelisted it, we would let that connection go through using that certificate. This is what you can also use for test certificates as well. So this is these are the two new features which we have announced, further strengthening the security profile of application gateway, and therefore for all your backends. What it enables you, of course, you can centralize your entire security of your pool of backends at one central place. You can have one single SSL policy, and you can define that, hey, I will only talk TLS 1.1 or TLS 1.2 and not talk any other versions. You have one single place where you have security rules. Today they are core rule set. We will also allow in future for customers to upload multiple custom rules, which are more security rules, which would be specific to sites as well as global. So we would allow that you could upload a global rule which blocks, let's say, an IP block based on X forwarded for header. So that is something which we would allow on a global scale, on a global level, as well as a site-specific policy level. You can run WAF as an external facing or an ILB enabled firewall. So application gateway can be deployed with a public facing endpoint as well as a private endpoint. And your WAF can be configured on both. So you can protect your traffic which is coming from outside, and you can protect them. Or you can configure the WAF in an internal load balancer, internal facing mode, and it would protect from other applications which might be talking within the data center or from other places. You can protect up to 20 web apps with our WAF solution. Your web apps can be distributed in a complex topology. Application gateway is not limited to one availability set. Your applications could be distributed across VNets, multiple VNets which are paired together. And therefore, you can have complex web application topology, and you can protect all of them with one single WAF solution. Since we generate every alert which is triggered, since we log them, you can have compliance logs. There are many compliance rules for many organizations which require that every publicly exposed endpoint should have a WAF. So you can fulfill your compliance requirements with the logs, with the data which we generate. And the integration from Azure Security Center for alerts and health monitoring will give you additional peace of mind. Other than that, other than the security features, we have also announced new features, capabilities in logs. We have already had a rich set of diagnostics logs. These included access logs, where each and every request to application gateway was logged and sent to the Insights RP, and it flew from there to the customer's storage account. So apart from access and performance logs, we have now announced availability of backend health logs. This is a real-time API. When you call it, at that point of time, it tells you what is the backend VM health looking like. So one thing to note over here is that you can have multiple services which are running on the same VM. For example, here, I have one pool, which is VM1 and VM2 are two constituents of that pool, but both are running the same two services, 80 on service on port 80 and another service on port 90. We have two probes which are going and actually probing at the application layer. They are not probing just the VM whether the VM is up or down. They are probing whether the application at port 80 is up or not, whether the application at port 90 is up or not. So the health status which you get back gives you the health of all the applications which are running across all your backend pools. So here we have pool 1, which has two VMs running two applications on port 80 and 90, and both are healthy, whereas VM2's pool 1, the one on running on 80 is unhealthy, and it indicates that. We also announced availability of application gateway metrics. If you're familiar with the Azure portal, there are logs, and then there is a metrics API, which shows you the continuous graphical representation of what is your statistics at one point. We have integrated throughput with metrics. What it allows you to do, apart from just seeing the throughput on application gateway in real time, it also allows you to set up alerts on these throughput. So for example, if your throughput goes beyond a certain threshold, you can today set an alert, and that would send an SMS, a mail, or you could integrate with webhooks and integrate with a SMS provider, which could send you a SMS or call or whatever. So we have integrated this with alerts. We also announced a couple of more features. We now support WebSockets natively in Application Gateway, and we always supported one extension headers, which is X forwarded for. So when the request flows from Application Gateway to the backend, what the IP it sees is the proxy's IP, the Application Gateway's IP. X forwarded for lets the backend see the real IP of the client who had made the request. But at that point, we had not supported two more headers, which were increasingly asked for. These were, what was the port on which the request came, and did it come over HTTPS or plain HTTP? So now we support two additional headers, which is X forwarded proto and X forwarded port. So those are the new enhancements on the Application Gateway side. I would show a little demo of these enhancements. So I would log on to the portal and show you how easy it is to configure the WAF, how easy it is to enable the WAF solution. So once it loads, I'll go to Application Gateways and show an existing gateway, as well as show a flow for a new gateway. So I have pre-created a gateway with WAF enabled on it, and you can see how to configure on an existing gateway. The new additions over here are this WAF SKU. Earlier you had just option of standard SKU. Now all you need to do is choose the WAF SKU and choose your instance sizes. We offer WAF in just two sizes, medium and large, and choose your instance count. And once you have chosen, you just have to choose the firewall mode. Right now, this particular firewall is running in protection mode. You can choose it to run in detection mode. And that is about it. That is the configuration you need. The only other thing which you need to do is how to get access to the diagnostics logs, the logs which the WAF is going to generate. And for that, you go to the diagnostics log section, and you just configure it over here. I have already configured the logs over here, so you can see that it has configured access log, performance log, and application gateway firewall log. On a new, let's say I wanted to create a new application gateway and I wanted to create with WAF, I just go to create a new application gateway. And I'll give, let's say, new WAF solution. I will choose the WAF SKU, and I will just, let's say, create a new resource group. It validates that. And in the settings, I just have to choose two things, whether my firewall is enabled or not. By default, it is enabled. You can switch it off. And whether it is running in detection or prevention mode. You can create prevention mode, choose prevention mode. And of course, I need to give I have to choose a virtual network and give a subnet to it. But essentially, what I wanted to show over here was, these are the normal steps which you would do to create an application gateway. The new additions are very simple. It's very easy to configure, and you can just hit create. What I have done also is created a application gateway firewall with all the major components already enabled. So let me show you the template for that. I'll go into a little details of how to configure all the three choices which I talked to you about, WAF, as well as end-to-end SSL and SSL policy. So to create the WAF, you would just choose a WAF SKU. And here, let me go to the section. Here you can see that I'm choosing a WAF SKU. So my SKU name is WAF, and I have chosen WAF medium. And the only addition, as you saw in the website, was whether it is running in what firewall mode it is running in. And for SSL policy, it is again a very simple configuration. I have a SSL policy defined over here, and I'm saying I will only allow TLS v1, disallow TLS v1 and v1.1, and only allow 1.2. Similarly, to create an end-to-end SSL, I have uploaded an authentication certificate. I have created my own test certificate, so I have to whitelist them. So here I have created an authentication certificate which contains the public key portion of the backend certificate, and I have associated that with a backend HTTP setting. That is the only change which we need to do. So here what we are saying is that this backend HTTP setting has an authentication certificate, and that is it. Now we can go and see this particular application. This is running at this particular address. It is running 52, and it is some 768. I can try and ping it. I can try to access a resource on it using curl. I'm trying to force that I will only use TLS 1.1. And if I try to do with TLS 1.1, it just disallows it completely. Now let's try with TLS 1.2. If I change it to 1.2, which is not in my disabled mode, it does allow and the connection comes back. If I try TLS 1.0 also, it should similarly disallow that. But more than that, the backend is running only SSL. And you can see that the backend, I have opened a public endpoint, but you will not use, you will not open in your real production environment. But just to show that it is running only SSL, I have opened the public endpoint, and this is just HTTPS running. And if I try to connect to the gateway, through the gateway, the traffic flows from the web application all the way to the backend. So I'm trying to hit the public IP. Again, these are test certificates. That's why it's giving me a warning. But here I have configured just SSL on my backend, and I am hitting the application gateway on SSL, and it is going to gateway, decrypting and re-encrypting and going back to the backend. I wanted to show a few of the exploits. Let's see a simple one. If I try to access using IP, the WAF would straight away reject it. It says, hey, you cannot access it using IPs. You have to use a qualified name. So let's say I try to do something which is, I cannot do it, not do it very easily on browser, but let's say I try to try to access the firewall with, I'm doing a GET, but at the same time I'm trying to supply a data. Again, if I try to do that using curl, it will detect it as a protocol anomaly that you are doing a GET and trying to supply a data, and it would send me a forbidden access. You can see the firewall detected that and said, you do not have, you are doing something which is not correct. Similarly, if I try to send another anomaly, which is I'm sending a user agent which is blank, which is what a lot of exploits also do, WAF detects that and says, hey, you are trying to do something bad, and it says forbidden access is denied. One thing which I wanted to show was that how easy it is to write an application which is unprotected. Let me go directly. Note that I'm going to the backend application, and I can write an exploit over here. Let's say I say common, and I can write an exploit very easily on most of these websites. Let's say it just says an alert and says exploit. And my backend is completely unprotected, and it let me send such an exploit all the way to the backend. But if I try to do the same kind of thing through WAF, it would detect it, and it would disallow such a attempt. So let me try to do something like which seems like a SQL injection. What I'm doing here is I'm sending an information which has a product PHP ID, and at the same time I'm saying 1 equal 1. That is a very common known pattern on and it detects that. It says, hey, you are trying to do something which is funny, and it just detects it. And similarly, let's say I'm trying to send the same kind of exploit and say, here I'm trying to pass a few additional URLs, and it detects it, and it disallows all that. So in the demo, we have seen that it has a SSL policy enforced. It is sending backend traffic in SSL, and it has WAF enforced, which is detecting SQL injection and common cross-site scripting exploits. So with that, I would like to conclude the demo. And for any questions, please let me, Eric and Jonathan know if you have any questions or any other information if you're interested in.